Hi, this is Derek Dailey, and today I'm going to be going over my big even circuit design process. What is this circuit called big even? Well, it accepts the unsigned binary output from a 10-digit keypad and will output a high value only if the input is an even number larger than 3. Now that we know this basic information, let's get right into the design process. Step 1, define specifications. So, we know that it is a 10-digit keypad where the input is coming from. So that means the input could be a decimal range 0 through 9. We also know that it's going to be in the form of unsigned binary, and in order to reach that 9 value, we have to have 4 bits in order to count that high. But with that being said, 4 bits can count to 15, and we only need the first 9 values. So we'll keep that in mind for now. Output is high only if input is an even number larger than 3. So if we take a look at the number range 3 through 9, in even numbers only, that'll produce 4, 6, and 8. Those are the only valid input answers that'll create an output of high. Step 2, define inputs and outputs. Well, it's 4 bits, and we need 4 inputs. So I wrote A, B, C, and D for inputs, and I wrote Y for outputs, because only one output is necessary. Step number 3, truth table. So as you can see, I wrote the inputs and outputs in columns on the top, and the decimal range from smallest to greatest on the left side in each row. So, as you can see, 4, 6, and 8 are only values that are high, as previously stated, and all the rest are low. And we know that we can only accept the decimal range 0 through 9, so the values 10 to 15 get marked as don't care values. So, here is the full truth table. So, using the truth table, I was able to fill out where each output is high and the don't care outputs as well to form the wraparound groups that are present. As you can see, we have one red and one green one. I will use these in step 5 to develop my Boolean equation. If we take a look at the green group, A stays consistent, so and it is high, so we write down A, and D is also consistent, but it is low, so we write D prime. The other two values, C and B, change, so we discard that. That creates the first AND on the left side of the equation. And since there is another way, another group, we OR that together, and if we take a look at that red group, we see that B is consistent and is high, so we put B down, and D is consistent but low, so we complement that. And as we can see, A and C aren't consistent, so we remove those. We have both of our ANDs via the groups, the red and the green, ORed together, and that creates our Boolean equation in its most simplest form. Step 6, create our logic circuit. So, we're going to be heading over to LogicSim, which is a nice handy software which allows us to create a circuit from this equation. So, at the top we have all the tools we need, and I will go over each one as we get there. So, let's start with our inputs. We know in the equation, which I wrote right here, that we have 3 variables or 3 inputs. So, let's go to the input, which is this thing right here. Let's add our 3 input pins. Just like that. You just click on it, hover over, and drag onto the canvas. That's how majority of this works. So what I like to do next is I click on each one and I label it just to say nice and organized. So this one's going to be A. Oops. This one's going to be A. This one's going to be B. And this one is going to be D. Perfect. Alright. So, we have our inputs. Now let's get our output, which is Y, as seen in the equation at the top. So, this is the output button. As you can see, I dragged it over. I'm going to click on it and change the label so we know that it's Y. Perfect. So, as you can see, I'm clicking things with this cursor tool, which I use to highlight and move things. So I'm going to move over the Y just to give more space for our operations. So I say we add our gates next. So we have two AND gates that are ORed together. So let's add our AND gates first. Over here are gates, and this is our AND gate. So let's click that and drag it onto our canvas. Here we go. I'm going to put these adjacent to one another. There we go. So we have our two AND gates, and the next thing is our OR gate that ORs together these ANDs. So here is the OR gate. I'm going to put it right over here. Plenty of space. There we go. Alright. Now, before we start making connections and connecting the circuit, you have to realize that the D is complemented. So, let's put a NOT gate. This is a NOT gate. Let's drag it in front of the D input, just like that. Alright. So, using the wiring tool, which is next to the cursor, we're going to start connecting everything. So, A and D, D, not D, is put into one, and B and not D is put into another AND gate. So, I hover over the entrance, or the place where you're able to start wiring from the input, and I dock it right to this blue dot, which is where the input goes into. Here, we know that D is knotted for both, so let's just hook the D right into the knot, so everything that comes out of it is knotted, which is exactly what we want. So the first one is A and not D, so let's finish hooking up the knot D, and there we go. That's that one. And let's repeat the process for the other one, dragging wires to connect the B and not D into the input slots for each AND gate. Perfect, just like that. So, we went over that part. Now, let's wire both of these ANDs into the OR, because remember, both of these AND gates are being ORed together. So that is naturally the next step. Here I'm wiring the output from the ANDs into the input to the OR. Now that we have that completed, we're going to have the output to the OR, which at this point is the output for the whole circuit, and that's going to go into Y. So now Y is equal to AD prime plus BD prime. There we go. So, we went over how to place inputs, outputs, gates, and wires, and to label things. Let's go over how to actually test our completed circuit. So, now that it's complete, we're going to be using the poke tool to change each input, and it's actually quite simple. You just hover over, and you click each one. So now we're going to test each input combination. 0, 0, 0 is off, which is correct. 0, 0, 1 is off, which is correct. 0, 1, 0 is on, which is correct. 0, 1, 1 is off, which is correct. 1, 0, 0 is on, which is correct. 1, 0, 1 is off, which is correct. 1, 0, 0 is on, which is correct. And 1, 1, 1 is off, which is correct. So now we have fully tested that this circuit runs exactly how we want it to. So we went over how to use majority of the tools and how to test a completed circuit. So this right here is the big even. I hope you enjoyed, and have a nice day. Thank you.